around the world, an air conditioner was a luxury good, something for the wealthy and the privileged. But this is changing, and fast. Today, cooling systems, which include air conditioners, account for 17% of global electricity use. These systems also encompass the refrigeration systems that keep food safe from the farm to our grocery store. They also include the cooling systems that data centers use to make sure that you can post that all-important picture on Instagram or Facebook as fast as possible. But what makes this a burning question, what should alarm all of us, is that our energy use for cooling is expected to grow six-fold by the year 2050. Today, it accounts for about 8% of global greenhouse gas emissions. This growth that we expect to see by 2050 is, however, not going to be evenly distributed around the world. A recent study that looked at this growth pattern from the International Energy Agency showed that most of the expected growth in our use for air conditioning and refrigeration systems is going to come from hot and tropical places in the world where people today don't use air conditioning and refrigeration systems as much as people in the developed world. So as you can see on this graph from the IEA, this includes countries like India, as well as other fast-growing countries like Indonesia, and regions like the Middle East, and you'll also find Mexico on this plot. It's a relatively small fraction of the world's overall consumption of cooling, but there's expected to be significant growth here as well. But one of the most alarming things about climate change is that the warmer our planet gets, the more we're going to need cooling systems. Systems that are themselves large emitters of greenhouse gas emissions. This then has the potential to make air conditioning alone one of the single biggest sources of greenhouse gas emissions by later this century. I was just in Delhi in India at a conference where a report was released that projected that residential air conditioning systems, the kind of systems you may have at home today, may account for 0.5 degrees Celsius in global warming by the end of this century. Just keep in mind that the UN Panel on Climate Change has set a target of 2 degrees Celsius warming over this century to make sure we don't experience really negative impacts. So 25% of that warming could come just from air conditioning systems. So my burning question really is, how can we keep cool, but do it in a sustainable way on a planet that is getting warmer? Now, I'm a scientist who studies light and heat. In particular, how new kinds of materials can allow us to manipulate these basic aspects of nature in ways we might have once thought impossible. So while I always appreciated the value of a good air conditioner, I actually started working on this because of a bit of an intellectual puzzle that I came across many years ago. How were many ancient cultures able to have ice and make ice, even in desert climates? To answer this question, I'd like to take you to this building. It's what's known as a yakshal, or an ice house that's located in the southwest of Iran. There are ruins of dozens of such structures throughout the Middle East and evidence of many other ancient cultures making use of this kind of cooling approach, including very likely Mesoamerican and ancient Latin American civilizations as well. At the pool you see on the left, the people that operated this ice house in winter months would pour water out into that flat pool. Now, even though the air temperature was usually well above freezing, the water would freeze. The generated ice would then be taken and used throughout the rest of the year by storing it in the building you see on the right. In fact, you may have experienced something very similar. If you've ever seen frost form on the ground, that's ice on the ground, even though the air temperature might be 5 degrees Celsius or even 10 degrees Celsius, so well above the air temperature. But wait, how did that water freeze if the air temperature was above freezing? Think about a pie that's cooling on a windowsill. For it to be able to cool down, its heat needs to flow to somewhere colder, namely the air that's surrounding here. But in this case, the air is actually warmer. So where did it go? As incredible as it sounds, the heat from that pool of water is actually going to the cold of outer space. How is this possible? Well, that pool of water at that ice house, like all natural materials, sends out its heat as light. This is a concept known as thermal radiation. So this is a basic feature of nature. All objects will send out our heat as a form of light. And depending on your temperature, it's at a different part of the spectrum. For most of us right now, we're actually doing it right now at a part of the spectrum we can't see. It's called the infrared part of the spectrum. But you can visualize it with the thermal